showed from the previous video lectures how to obtain the expression for calculating the internal energy change and the enthalpy change, which you are seeing right now on the screen. So you have du and dh. And for perfect gases, yung second term ng parehong equation na nakikita ninyo will be approximately equal to 0. So that to get delta U or delta H, you have to integrate lang yung first term, which is yung CVDT or CPDT respectively. Nung nakaraang video lecture din, napag-usapan natin ang reversible processes, and we show how reversible processes will give you the maximum work na pwedeng ma-obtain tung sa process. So let's now identify conditions and derive equations for such reversible processes that involve perfect gases. So, umpisahan natin sa isothermal conditions. So, pag sinabi natin isothermal, constant yung temperature. Okay? And, since we know na yung delta U natin, which is, I will write here again, equal siya sa CVDT integral, and yung delta H naman natin is equal to the integral of CPDT. And take note that both integrands depend on temperature. Pero kay isothermal conditions, constant kasi yung temperature. Ang ibig sabihin lang niyan, delta H or delta U first will just be equal to 0 because dt is 0, and delta H will also be equal to 0 because this equation is just a function of temperature, which is in this case constant. Okay, so that's how you calculate the internal energy and the enthalpy for an isothermal process involving reversible processes involving perfect gases. Delta U and delta H both 0. Now, remember that delta U is Q plus W. Pero delta U is 0 already. Napatunayan na natin yan. So kung delta U is 0, so let's just write there 0 equals Q plus W. Ang ibig lang sabihin yan, Q will be equal to negative W. But we don't have an expression for W. So far, ang meron tayong sagot is the following. We know delta U. We know delta H. If we know W, we will be able to calculate Q. So, ang susunod na lang natin gawin is to determine kung paano makuha si W. So, paano nga ba? Remember, we are dealing with perfect gases. So, if the gas is perfect, it will obey the ideal gas equation, which is PV equals nRT. Now, let's solve this equation for P. So, P will be nRT over V. Correct? Okay. We will use this expression kay expression of work. So if you remember, work, diba, is minus PdV for reversible processes. Okay? Or change in work is minus PdV. That's why work is the integral of minus PdV. But what is P? So nakita natin from the ideal gas equation that P is nRT over V. And then you have a dV here. So we can now integrate both sides of the equation. And what will happen is you will be able to calculate work. And since minus nRT is constant, kasi isothermal tayo, ang matitira na lang dun sa integration is dV over V. And the integral of that is ln, or natural logarithm of v. So if we integrate from initial state 1 to a final state 2, then you will get v2 over v1. So that is now our expression for work done in an isothermal reversible process. Of course, you can make the minus sign positive, pero yung ln will be v1 over v2. So you now have the four equations for isothermal processes. Now, the next type of process that we will consider is an isobaric process. Paano kapag isobaric? Constant pressure po yan. Yan ang ibig sabihin ng isobaric. So, if the pressure is constant, what will happen to our delta U and delta H? So remember, delta U is just the integral of CV dt. Okay, so wala kayong magagawa kundi gamitin yung equation na yan. And ganoon din kay delta H. Integral from initial state to the final state of Cp dt. But how about yung work tsaka yung heat? Okay, bago tayo pumunta dun sa work, pag-usapan muna natin yung kay heat. Now remember, from the expression of enthalpy, alam natin na dH is equal to dQ plus VdP. Napag-usapan na natin yan, or na-derive na natin yan before. So, saan ba yan galing? Diba, galing yan sa H equals U plus PV. And therefore, dH is du plus differentiate yung factor PdV plus VdP. But du is here. Wala pala dyan. But du is dq plus dw. So, plus PdV plus VdP. But dw is minus PdV. So, plus PdV plus VdP. Of course, may similar terms na nag-appear sa equation, which is minus PdV and plus PdV. I mean, they cancel each other out because they have opposite signs. So, ang matitira therefore, dun sa equation na yan, is itong tinutukoy ko dito. Okay. However, sinasabi nga natin, for isobaric process, constant si pressure. So, kung constant si pressure, makakancel mo tong VdP na to. So, ang natitira, therefore, is dH equals dQ. So, if you integrate this, ang mangyayari, Q will be equal to delta H. So, that's how you obtain the third relationship. So, meron na tayong delta U, delta H, Q. Ang natitira na lang is si work. So, how do you obtain an expression for work? So, just remember again, dW is minus P dV. Okay? So, ang mangyayari, W will be equal to minus P integral of dV from 1 to 2. Okay? Now, let's say na yung P is just equal to the P external. Kaya kung ginawang constant si P dito, so lalabas na ang W natin magiging minus P delta V na lang. Okay? For an isobaric process. Now, Let's expand this further. So, magiging minus P. So, yung delta V will become V2 minus V1. But, from the ideal gas equation, naalala mo, V equals nRT over P. So, minus P, yung V2 will be nRT2 over P minus nRT1 over P, where P is constant. So, what happened is, makakancel natin si pressure. So, cancel yan, cancel yan, cancel yan. So, ang lalabas therefore sa equation na to, for an isobaric process, W is equal to negative N R delta T. That is how we get the fourth equation, which is for work. So we're done with isothermal, we're done with isobaric. So ang susunod is constant volume naman. So pag sinabing constant volume, it's an isochoric process. Sometimes we call it isometric. And some others call it isovolumetric. O basta ang tatandaan nyo lang, constant si volume. Okay. So how do we get delta U? O di ganoon pa rin, integral of CV dt. Delta H, the same. Integral of Cp dt from initial to final state. How about work? Si work, di ba? Work is minus PdV. Okay? Isochoric nga tayo eh. Constant volume tayo. So therefore, work will just be equal to 0. Kasi meron kang dV. dV is 0, so work is 0. So that is the third equation. Sorry. So ang kulang na lang dito is si heat or si Q. So how do we obtain an expression for Q? We know that delta U is equal to Q plus W. But W is already 0. So therefore Q is just equal to your delta U. So whatever you obtain here, yan na rin yung heat. Ibig sabihin lang yan, kapag constant si pressure, which is usually the case sa mga lab activity noong college, constant si pressure, which is just atmospheric pressure, yung heat na ma-obtain natin is just your delta U. Sorry, I was talking about constant pressure. Constant volume pala. Okay. But we have seen earlier from the constant pressure process na yung heat is just equal to your enthalpy. Anyway, yung last na klase ng reversible process na pag-uusapan natin is yung tinatawag nating adiabatic process. So, remind ko lang kayo, no? Lahat ng tinutukoy ko dito is reversible process involving perfect gases. Now, for adiabatic, ang ibig sabihin lang yan is there is no heat transfer. So, therefore, Q is equal to 0. So, yung given condition agad, yun na rin yung equation natin. Q is equal to 0. Okay, how about the others? Well, the same, no? We'll have the expression for delta U and delta H, which is this. So I'm just copying it. There. Okay. Ngayon, ang susunod nating pag-usapan is yung work. So, alam na natin yung delta U, yung delta H, tsaka si Q, si work na lang. So, from delta U, which is Q plus W, tatandaan natin yan, that's just the first law of thermodynamics. But Q is already 0, so therefore, work is just equal to delta U. So, those now are the four equations for a reversible adiabatic process. Okay, so kung titignan nyo, napakadaming conditions. We have isothermal, isobaric, isochoric, adiabatic. And for each, mayroong apat na equations to calculate delta U, delta H, Q, and W, although some are redundant already. Pare-parehas sa ibang cases or conditions. And this set of equations might kind of overwhelm you kasi madami sila. You have 4 times 4, 16 total equations, right? Mahirapan tayong i-memorize yan, but ang tatandaan nyo lang is how you obtain them in the first place. So, tatandaan nyo lang perfect gas to, and tatandaan nyo lang reversible yung process natin. So, ang kailangan nyo lang talagang maalala is number 1, kung anong klaseng condition ba yan, constant temperature, pressure, volume, and given the equations that we have learned so far, you can reduce those equations to get the final set of equations for each condition. So, in other words, ang tatandaan mo lang naman talaga dito ay yung expression for delta U, which is, yun nga, again, isusulat ko ulit, integral of CV dt. Yung expression ni delta H, integral ni CP dt. Yung ideal gas equation, PV equals nRT. And yung first law of thermodynamics, which is delta U equals Q plus W. Yun lang. Yan lang yung apat na tatandaan natin, plus yung conditions na given. And from these four equations, you will be able to derive all of these equations that we discussed so far.